looking at the relays here just a little bit closer, we've got an LGB relay here, and that's controlling the block on the outer track. The blocks are between the red note cards, are about 35 inches long. You can see this note card here, and that red note card back there shows the end of the block. Likewise on the inner siding, the end of the block is here, and the other end of it is back there by that red note card. That's the insulated section controlled by these relays. Is about 35 inches long. This relay here controls the outer track, and this is an LGB relay, and you can see if I manually move this arm, I can control this one manually. I can turn that on and off. When the arm is over in the left position, it's off. You can see the light is off. When the arm is over in the right position, the light is on. Now, so we can manually control this relay, and we can also visually see what position it's in by looking where the arm is. Now, the inside loop is being controlled by an ASA-Trax relay, and these two, although they look different, are doing the same function. You could have two of these or two of these in either case. This relay, there's no arm to control it manually, but the LGB switch cat that's controlling this, I've got a pair of buttons that was made for me by my late friend Fred Cupp, which we can plug into the end of the switch cat and manually control this. And switching the buttons, you can see that light just went off on the inner siding power connector, and likewise I can turn it back off with the turn it back on with the other button. So there's off and there's on. And I'm going to shut up for a second and switch that, and you should be able to hear that thing clicking. You can hear that relay shifting. So those are the two relays controlling the stop blocks that stop and start the trains. And in our rear, the rear turnout back there, I'm calling that the diverging turnout when I call it correctly. A couple cases I called it converging, but I called it the diverging turnout back there. We can manually control that. Again, we've got an LGB switch it controlling the relay that controls the turnout, and we can manually control that. Right now it's in the curve position as indicated by the red. There I can manually throw it to green. You can see the light went back to green, and there's red and green, so on. So that's a way we can manually control that turnout if we want to run this layout manually. And the switches are running on, the turnouts are running on constant power. You can wire these up so they get constant AC power from the transformer, so they're not dependent on track power, which is good because like a Docksider doesn't need that much voltage, and you may not have enough voltage to firmly throw the switches, to firmly throw the turnouts. Now this front turnout here right in front of the camera, calling that the converging turnout when the tracks come together. That one just using the MTH automatic feature that lines it up. If I short these rails with a wire, which is what would happen when a loco comes by, you notice it's straight right now. If it's curved right now, if a loco is coming along on this track, it needs to go to straight, and you can see it went to straight. And if a loco is coming along on this track, it needs to go to curved, which it went to curved. That's actually if this light turns around the other way. But you can see how the automatic switching feature is working here to throw this in the right direction. There's straight. Now it's straight. If a train comes down the curved track, goes to curved. Now we have a red status light on the mini panel that blinks when it's executing commands, sending commands. It's not on now, but if we push this red button here to start it executing, now you can see that red thing is blinking. And basically what it's doing is it's going down through the program, checking these inputs to see if any of them are closed. In other words, which of the two trains to run, or if we close this switch up here, run the test routine. But everything is open right now, so it's not doing anything, but it's still checking these inputs. Now if I close the switch for the inner siding over there, it'll start executing that program, and you'll see that dock sider should start up. So that we can, now what it's doing is it's not blinking anymore because it's waiting till the dock sider gets back to the detector and so on. But the point being here, you can actually again use this as sort of a test. You can tell when that's blinking that it's kind of executing the program, whatever it is. Let's take a look at the indicator light on this switch at MK2. You notice it comes up dark and then it blinks a 1, and then it blinks up briefly three horizontal lights, and then it goes into what they call a wigwag signal, and that just tells us that that thing is running on DCC. And also, if we push this button here, you can see it displays a 5. That tells us the left output is accessory number 5. If we push it again, it blinks a 6. That tells us the right side of the thing is accessory number 6. Then if we push it again, it shows us 5. Apparently, I was thinking it went back to the... There it goes back to the normal wigwag signal. Not that this is critical, but that just tells you that's receiving a DCC signal. We're going to look at this MTH turnout hookup in more detail. What I'm holding in front of the camera right now is a sketch from the MTH instruction manual, and they define basically what these 5 terminals on the turnout do. And this drawing is included as part of the wiring diagram, which we'll go over later. And it should be noted, this is unique to the MTH turnout. We're using a latching relay to control this turnout, and if you do it with any other 3-rail turnout, it'd probably burn it out, because the MTH has limit switches in the bottom. You can keep the contacts connected, but any other brand, it would probably burn out the solenoids. Now things are simpler for HO scale, S gauge, or LGB, and we've demonstrated that in previous videos controlling those type of turnouts. The most complicated is probably the O gauge, because you have the turnout power that actuates the motor connected with the rails, so you can't just hook something up to the motor like we would for LGB, because we'd be putting DCC power or power from the DCC system into the rails, and I don't think it's a good idea to mix up the 2 power sources. So again, just keep in mind what I'm saying here is, as far as I know, unique to MTH turnouts. Now let's take a closer look at these terminals. There's actually 4 ways we can control this thing. We can use the controller, which is, you see I'm doing here now with my hand, and we can set it to curved, red, or green, straight, and that's probably the way it's designed to be used. And you can use a self-derailing feature, would be the second way. We're using this in the video on the converging switches up front. We use when something comes along and metal wheels from a locomotive hit the rail as the train approaches the turnout from coming in this direction, it automatically aligns it in the correct direction. As you can see, it's doing here. That's the second way. And the third way is you can just manually turn this thing, and like I'm doing here, and you can see they've got some kind of smart circuitry in there that actually illuminates the correct bulb on the controller, even though we're not using the controller when we do it manually. Now let's talk about the 4th way, which is what we're using in this video and going over these terminals. This terminal is from Track Power here. This terminal is hooked up to the center rail and is normally jumper to this terminal, which is your positive power. So if you leave that jumper on, you can use track power to throw this turnout. However, we wanted to use auxiliary power so we'd have a good strong power signal even when we're running the train slow. So we remove the jumper that's between these two terminals when you get the turnout and put that jumper away in a safe place. So this screw you connected to the track is not used as we're using it here. This is our auxiliary wire. This goes over to the plus side of this transformer, so that's bringing power in. And then these three terminals are what you hook up to the controller. You can see the black, red, and the green wire going to the controller. Now here's how we're doing it in the video. By experimentation, we find if we hold a wire on the black terminal and we touch the red terminal for curved, we can switch it to curved. We'll try to show this with my hand being in the way a little bit less. This dark blue wire is connected to the black terminal on the turnout, and if we touch this black terminal to the red terminal here, you can see it goes to curved. If we touch it to the green terminal, it goes to the straight, and so on. And so if we take this terminal, this wire here from this terminal and hook it to the center of our relay, and then connect the two outside terminals on our relay, the output terminals, calling this the input terminal, to the center, and connect the other two terminals, the output terminals, one of them to the red and one of them to the green. The relay will perform the same function as we're doing here with our hand manually touching these wires. And again, to repeat, the relay essentially is not only touching, it's holding. I'm holding this wire on that red terminal. The relay is doing the same thing. It's holding that, and so it basically locks the relay in that position. You can see the turnout doesn't want to go the other way. So that's how it's done. One thing we should mention about this turnout, it's controlled by a third relay on the control board. It's an NCE dual relay, but it essentially holds it in whatever position you've set it for. In this case, it's straight. But if we try to manually turn this, which is how you can normally do with an MTH turnout, you can see it buzzes and it doesn't want to go there, and it wants to stay in that position. And likewise, you wouldn't want to back a car with metal wheels in from this direction onto these rails, because that would try to change it to curved, but it's trying to stay straight because of the relay holding it there. So you'd have the thing being activated in both directions and probably a short, which wouldn't be good. Now let's take a closer look at this control board, and we'll look at this stuff again when we go over the wiring diagram later. The wiring diagram pretty closely follows the layout shown here. If you've seen any of the previous videos, the brown part here is what was used for the last video controlling 6N gauge street cars, and then what's on the green was added to do this O gauge video, which consists of the relays to control the stop blocks and the relays to control the turnout back in the rear, plus the status light. Kind of moving from left to right, we have the NCE power cab over here, which is supplying the power to the system, and it's powering the mini panel, which is our controller, and it's powering these three components here plus the relays. But the actual track power and the power to control the turnout is coming from that Lionel transformer sitting over there on the left. That's just a old conventional Lionel transformer that we're using. It could be basically any brand of AC transformer as far as I can see. Now back to the control board. This is what they call the power control panel, PCP, and it's part of the power cab. It just connects the power cab to whatever else you're going to use it. This is the power going out to the out to the components here, and this cable's going over to power the mini panel. And then we have a push button, and this push button is wired in parallel with that one you've seen me earlier pushing. It's down here out of the camera. That's why that push button on the board's wired in parallel with this one. Either one of those two push buttons does the same. It grounds input 1 and starts the trains up. And then here is our mini panel, which is the programmable train controller. This switch here is used to disconnect DCC going to the track. It's not used in this video because we're not using any DCC trains in this video, although we could have a DCC train connected to this layout. But it allows us to disconnect any detectors and stuff. So if we want to program a DCC loco on the main, we disconnect that load. And then going over here, we have these. There's 6 toggle switches here which control various things. Another toggle switch here, which we call the repeat switch, which we just used to keep it going versus a single cycle. Up here, I've got an old knife switch which we're using to activate the test routine. But all these switches are doing the same thing. They allow us to ground an input of the mini panel to tell it to do something. And incidentally, those toggle switches, like these things here, the latest ones I added with the red tops, they come from, I think I got these from Amazon, I believe. And they're all, it's kind of nice, they're already wired up, which is why I've got all this extra wire. I never bothered to shorten it, but I'm not particularly great at soldering, so anything I can find that allows me not have to solder something, I try to take advantage of it. And over here, these are NCE switch cats, is what they're called. They're meant to switch a Kato turnout, hence the KAT, COT for Kato, short for Kato, I guess. They'll switch an LGB turnout motor or a Kato motor, or they'll also switch these Asia-Trax relays. This is an LGB, actually an LGB switch motor, and if I put an LGB switch next to it, you can see this is basically the switch motor for the LGB switch. And then this you can plug in on the end, which is what's here, a double pole double throw points, which turns this thing into a double pole double throw latching relay. But notice this is real simple to control if you're doing LGB trains, which we've done in past videos, because there's no connection from this thing to the track other than mechanical. There's no electrical connection. But as I mentioned earlier, we've got to be careful with these 3-rail turnouts to not mix our DCC power with the track power, i.e. keep it isolated and separate. And these could be, you could have 2 of these or 2 of these. I just use 1 of each. The nice thing about the LGB is you can see where its position is because this arm moves forward, and in tradition with the past autocontrols videos, back is off or red and forward is green or go, which connects up the block. Now the disadvantage of this is it's more expensive, a lot more expensive than the Asia-Trax, and it is mechanical. It's actually got a little motor with a pinion and a rack gear inside, so it will wear out a lot faster probably than this relay. And LGB says these are rated for 3 amps, although I think they take a lot more to control some of those big large scale trains we've used. Asia-Trax I think says this is rated for 8 amps, so it should be plenty. Now this device is what they call a NCE Switch It Mark II, which is the latest version. There's earlier versions without the lights, but it's controlling this device, which is an NCE dual relay, which it has two single pole double throw relays on the same board, latching relays on the same board, which can be controlled independently. And we're using this one to control the rear turnout, which we demonstrated earlier, and using this one to control that status light. And the status light is just a little light I got off of eBay. Here's a loose one, and you could probably find something better. It's just something I had handy, but again, it comes with the wires, and don't know if it shows up in the camera, but on the there's already on the end here where my thumb is, there's a resistor, so you don't even have to mess with soldering the resistor on the end. They've done that for you, and you just hook it up. So since I had this thing handy, I used it for the status light. The status light on this system is just being held in place by one of those adjustable arms they make for holding parts when you're soldering them. The documentation for this video in the form of drawings, commands, photos, and stuff is on the website AutoControls-dot-wordpress.com, and look for video number 833. Also, there's a Getting Started video on the same website, Getting Started with the NCE mini panel, like how to program that, and on the same location, look for video number 816. Also included as part of the documentation is a rough parts list, including the NCE power cab and mini panel, switch cats, the LGB relay, Asia Trax relay, and the other stuff. And down here is the parts for controlling the MTH turnout. And again, note that these will vary for other types of turnouts. Here's the wiring diagram for this setup, and this is designed to print out as it's in the documentation as two PDFs, which you can print out as two 8.5 by 11 sheets, and then scotch tape them together at the vertical joint, which is about here. The left side of this shows pretty much the same controls as we've been using in the last dozen or so auto control videos. By the left side, I mean what's to the left, or where I'm wiggling the mouse here. And what's over here on the green colored board is the added parts to do this O-gauge video. So let's start at the left, and we'll kind of work our way from left to right. The video uses an NCE power cab. Now this drawing shows the Powerhouse Pro, but it basically all hooks up the same way. In the here's the mini panel, which is the controller, and shown here are those single pole, single throw toggle switches that control different things. And there's one more over here on input 25. That's the one we're using for the testing the detector. In the down here is our Z stuff detector, and this can be a DZ1011 or a DZ1012. It could also be a reed switcher or an electric eye. And as we mentioned, you want to position this immediately upstream of the diverging turnout. Now the power comes out of the NCE system on these. It's shown here as red and blue wires. I've been using RGB wires, so if I use a red, I think it's red, blue, black, and green wire, it comes in one four wire strip with these four colors. I can wire part of this up, but that shows the red and blue colors, which is the DCC power coming down to here and over to the Z stuff detector. And normally it would go out here to a track with DCC locomotives. In this case, we don't have any locomotives, DCC locomotives used in this video, although we could have. But you could hook up a DCC track to these terminals here. Now the DCC power goes over to the right on these wires, again, are red and the blue, and that takes it over to this terminal block, and this terminal block takes it over to the components on the right side. And this drawing is a little bit of a kludge because I had the board on the left already made up, and what I did is added all the stuff on the right by adding a green colored extension onto my control board. Now, as we continue to look at the right side of this control board, we see over here on the upper left, we see our red and green wires, red and blue wires, bringing the DCC power into the first switch cat and the second switch cat, and also up here bringing DCC power into the NCE Switch-It Mark II. So these are our 3 DCC components that are running on DCC power at the top here. And then these gray wires that you see coming out on the bottom of them going down to these 3 components, those are DC outputs as shown in this small note. And the switch cats basically put out a pulse of DCC, a pulse of DC power to activate this LGB switch motor for this one, or for this one to activate the AZATRAX relay. Now the Switch-It Mark II, that normally controls a tortoise turnout. That's probably what 99.9% of the switch-its do, but it'll also control an NCE dual relay. But these wires coming out are containing just a very slight, very low amperage, constant DC current, just like you put on a tortoise switch motor, but it's putting that current on the NCE dual relay. So let's go over and look at the relays. This is the LGB 12010 switch motor with a 12070 relay points plugged into it, which gives you a double pole, double throw latching relay. And if you consider the input to be green, which is track power coming from the power pack over here in the lower left, your variable track power, in the case of the transformer I have, it's terminal U, but that comes in here as the input and comes into the center of the 2 relays. And looking at the LGB relay, when the arm is in the right position as it's shown, that's the go position. That's what this note says here. Contacts are connected as shown when motor arm is shifted to the front block is green. That's consistent with the older AutoControls.org LGB videos. But when it's in that position, it connects this terminal 37 to terminal 36. And this violet-colored wire is shown on the drawing. That's going out to the track. You can trace that violet-colored wire over here to the stop block on the outer track. So that LGB relay is turning on and off this stop block, which was causing the red Chuggington locomotive to run or to not run when it came to the stop block. And then similarly, if we look at the AZATRAX relay, consider its input to be green to the center terminal, and when it's shifted to the go position, we have no visual means of that, but when it's shifted to the go position, again, the power comes out on the violet wire, and you can trace that violet wire over to the inner stop block, which was the blue Chuggington loco running. So there's our 2 relays controlling our 2 stop blocks. Now, as to the turnouts, we're using constant power, and that's what this terminal C on the old Lionel transformer I'm using does. We bring constant power out on what's shown in yellow on the drawing. In the front turnout that was nearest to the camera, all we have is 1 wire going to the auxiliary in to give it constant power. For the other turnout, the one back in the rear, we can follow this yellow wire up to this terminal block and in out over to the auxiliary input on this rear turnout. Now, the turnout's controlled by this LGB dual relay. We called it R3. And you can see the black which is negative on the turnout is coming into the center terminal on the relay, and then the outer relays are the red and the green, which cause it to go to straight or curved. So this relay R3 is kind of replacing the MTH switch controller. And I say kind of because the one thing it does differently, it's like holding the switch controller with your hand and in holding it all the time and not releasing it. So it basically holds this turnout in this position that doesn't buzz or burn out because of the limit switches that MTH has put in there, but it doesn't allow you to manually turn it to the other position. You got to actually switch it using this relay. And up here, and let's back up a little bit. You may recall in the video, they're not shown on the drawing, but these components, you can hook up push buttons up here, and there's push buttons on the one for the turnout in the video, and there's push buttons on the AsiaTrax relay. My friend, the late Fred Cupp, hooked up a pair of push buttons for me. I have 2 sets of them, and I'm using one here and one here, so you can use push buttons to manually control these things, which is what we were doing in the video. But like I said, they're not shown on the drawing. So I guess that's our main components. The final thing here is relay R4, and this, they call this a dual relay, and you've got actually 2 independent relays that you can control independent of each other. What we call accessory number 5 on this side of the switch it controls. You can follow those wires down to R3, and accessory 6, which is the other side of the switch it, you can follow those wires down to R4, so they can be switched independently. And we're using this relay R4 to control what we call our status light. That glows green when the system is not doing anything, and you can push the push button, but once you push the push button to start the system up, then this status light will change to red. And again, the DCC, we bring our plus DCC in here to the center terminal of this, and then we can use the red or the green wires to cause the red or the green LEDs to light up. So basically we're using the DCC power to power these components here, plus we're using it to switch the relays, the 2 relays, but the actual power to the track is coming from this Lionel transformer over here via the black wire for ground and the green wire for the center power rail. And we're using the power off this Lionel transformer to go through this relay R3 to actually switch the turnout, so that we're not mixing DCC power with track power coming from the transformer. So the relay keeps the DCC power independent, that is to say isolated from the Lionel track power that's actually switching the turnout. Here's the flow chart for this operation. If you're not familiar with flow charts, this just shows the logic of how this program executes. And just think of it as kind of like a pinball machine. Your pinball starts up at the top and it drops down through here, and if it either drops out the bottom or it goes around and executes again. But let's start at the top. It says the program starts running when the start button is pushed. So if somebody pushes the start button, that's connected to input 1, and the mini panel detects that and starts running this program. And the first thing it does is change the status light from green to red. Then checks a bunch of switches. And let's assume for the moment these switches are all open. When it first comes to this first test, if the switch is closed, it goes this way, but if the switch isn't closed, that means it's open. It just goes straight down. And likewise for these other examination of the switches, if they're open, it's N for no, negative, and it just drops straight through. Now if the repeat switch is closed, that's Y for yes. It'll follow this path up to the top and do the same thing all over again. And you may recall somewhere in the demonstration we did that. We had the repeat switch closed, but all the other switches open, and the red LED was blinking at about a half second each or twice per second, and that happens down here. There's a delay of a half a second. Let's say again all these switches are open. It comes to this thing and there's a delay of half second, and it blinks the LED. Whenever the mini panel sends a command, the LED will blink. So we can send a dummy command like to a turnout that doesn't exist just to cause it to blink. And if the repeat switch is closed, it'll come around here, drop through again, and come back to that blink command a half a second later. We need to have a little bit of a time delay because it appears if you don't have any delay in it and you try to blink this thing at infinite speed, it doesn't work. It terminates itself. But now let's go back to normal operation. Normally we're running trains. So let's start back up at the start button here. Let's assume we're doing the normal two-siding operation, and I put those in heavy green. This is what we'd be normally executing if this thing was running as a display layout. So if somebody pushes a start button, it changes the status light from green to red. The test switch is going to be open, so it doesn't do that. Now it comes to this examination of switch number 24, and if that's closed, it'll go over and run program B, which is the outer siding. And within that routine, we have tests on switch 20, 21, and 22, which are more one-time or longer station stop. And when it's done with that, it checks switch number 23, and assuming that one's closed also, it'll run the inner siding, and the same thing, it goes over and runs program 3, and within that program, there's checks on switch 20, 21, and 22 for the same things, more one-time and a longer station stop. Then it goes down to here, blinks the LED, delays a half second, and it checks whether that repeat switch is closed. If it is closed, it goes back, follows this path up to the top, comes down and does the same thing. So as long as that repeat switch is closed, it'll keep executing this routine over and over again. And if when the repeat switch is opened, it'll drop down to the change the status light to green and end. Now the other options we have is the test switch. That's number 25. So if the test switch is closed, then it'll go over here and run program A, testing the detector. Where if we run a car, in front of the detector to block the Z stuff infrared detector, it'll change the turnout and turn the two sidings on and off at 2 seconds apart, and you can see the lights and the connectors, the MTH connectors that connect to the track. You can see the lights go on and off. Then the other option, if you want to shut one of the sidings down and just run, say you just want to run the inner siding, if you open switch 24, which controls the outer siding, then when it comes down through here, it won't do this routine for the outer siding, but will do the routine for the inner siding. So you can run either siding without the other siding just by opening one of these switches. And then finally, if you want to do the blind demo, and that's the blind demo is where we ran it without using a detector. I'm calling it running it blind because you don't know where the train is. You're just using timing. If you close switch number 19, and you want to make sure these other ones are open, but close switch number 19, it'll run program D, which is the blind demo. And these 4 programs, we'll take a look at those in more detail in a minute when we look at the rest of the command file. But this just kind of gives you a high-level overview of how this thing operates. We're looking at page 1 of the command file. This page 1 is kind of a bookkeeping area. This first section says input toggle switches and programs used, just keeping track of what toggle switches are used to run which programs and which inputs they take up. This kind of overlaps with the drawing we just looked at a little bit. In this section is accessory numbers, what we've got our switchets and switchcats programmed to as far as accessory numbers. And then down here is the configuration memory of the mini panel. We're basically using the defaults except for address 3 and 4 is shown in red. We've changed them just a little bit. And then down here is what we call our command library examples. These are the commands we normally use in these AutoControls.org setups. And the number in red is what changes. So most of this stuff can be programmed in by hitting a sequence of four numbers. There's actually a command tree that NCE has that goes through all that, but you can distill it down to basically using these sets of commands and just changing the one in red to suit your particular situation. Like if we're using a delay, this says delay a quarter second times 4, which gives you a 1 second delay. But if you want a 2 second delay, you change this to an 8. So you've got 8 quarter seconds delays for a 2, and likewise for all the other commands. Here's page 3 of our command file, which contains program B from here down to here, and then program C from here to down to the end of the page. And program B up here is the one that runs the red loco on the outer siding, and program C down here is the one that runs the blue loco on the inner siding. And these are using the detector, and these are probably what's going to be the most used mode of operation for this program. Now we'll stop a second and zoom in a little closer. While backing up, let me say these programs are almost the same. They're almost identical, except we're turning on and off a different block for this program than that program, and we're throwing the turnout a different direction. But otherwise, the two programs are pretty much the same. Now let's stop for a second and we'll zoom in closer on the first program. Here's our program B that runs the outer siding, which has the red locomotive on it, and we're using the detector. And this, normally we're going to have this switch 24 ground to run this loco. So when it comes to this command, it skips over that link statement and comes down to here. And the green rectangles are where we have the statements, the commands that change the blocks, and the red one is the turnout. So when it comes to this command, we say accessory note 10 norm, which is normally throw a turnout to straight. But since we've got our switch cat connected to the LGB relay, that closes that relay and turns that outer block on, which starts the red engine up. And then we delay about 5 seconds, and then we throw the accessory 5 norm. That's throwing that turnout back in the rear, the diverging turnout. That's throwing that to straight, which we need it lined up to straight to have the train go onto the outer siding. So at this point, our turnout's aligned correctly, the power's on in the block, and our train is running. So here's our additional delay statements, which is switch 21 and switch 20. If these are closed, it adds additional delay. If they're open, it just skips over these statements and doesn't add that delay. So the next thing is check our detector. Our detector is hooked up, our Z-stuff detector and relay is hooked up to input 14. So this wait until input 14 goes to ground. That means the mini panel is doing nothing until we see that input 14 go to ground, which happens when the train passes in front of the detector and breaks the infrared beam. At that point, we say accessory 10 reverse, and the switch cat will throw the LGB relay. It'll open it and turn that outer stop block off. So that'll stop the train when it comes into the stop block. Now here's what we call our station stop, how long the train sits there before the next train takes off. And we have that set for 4 seconds, but we have switch 22, we can add some additional station stop. In this case, another 4 seconds if we close that switch. So again, you can see the switch 22 adds more station stop, and up here, switches 21 and 20, they add additional delays. You can put whatever numbers in here you want to make the trains go around 2 times or 4 times as we did in this video, or make them go around a lot more loops just by varying these delay statements. Now finally, that's the end of this program A. So it'll go down and check whether we want to run the blue loco, and if so, it'll do that, and if not, it'll fall through to the bottom of the program and check that switch number 18, the repeat switch, and if it's closed, it'll come back up to the top of the program, come in here at the top, and run the red train again. So now let's take a closer look at the program C for the blue train. Program C for running the program C for running the inner siding, which is the blue loco, again using the detector. And so up above here, we just talked about the program B for the red loco, and assuming it ran that program or if it skipped that program, either way it's going to come down to this statement's skip if toggle switch input 23 is ground. That's toggle switch 23, assuming we've closed that to tell the system we want to run that blue loco. Assuming that's closed, it'll skip over this link statement and execute this accessory 7 norm, which is the other switch cat, which will change the ASA relay to green to start up the stop block for the inside loop. And again, now the same thing, a delay, and then 5 seconds later we throw the turnout in the back, the rear diverging turnout. We throw that this time to reverse, which means curved, because we have to have the turnout set to curved for this to reach the inside siding. And now one comment on this timing: you could set this turnout before you start the trains up, which is the way I originally did it, and I moved it down here after we start the train up 5 seconds later, just to give if this other in case the other train was slow getting through that switch, to minimize the chances of that switch possibly getting thrown underneath the red train. What actually happens if I change engines, I put the slower engines on, like the Docksiders, they take longer to get across the switch, and this kind of protects those slower engines from the switch being thrown too soon. So anyways, and then here's our same delay statements is 4 to cause more loops, and here's our statement that turns the block off, and we're just using accessory 7 instead of 10 because we're using the other switch cat. And then our same as before, the station stops, and then we're done with running the blue train. Now here's our program D, which is what we call running blind with no detector. And we've used the term blind just because without the detector, you don't really know where the train is on the loop. It could be anywhere. But it's almost the same as the previous routines B and C put together, except we don't have the statement in it to examine the detector. So starting from the top of where this program begins, assuming toggle switch 19 is closed, which says we want to run this program, we're going to skip over this statement here and come to this statement, which turns the block on, same as before, which will start the train up. That's the that's the LGB relay, and then we have a delay of 5 seconds before we change the turnout, same as before. And that's this statement here. So the turnout straight, which we need to have it to allow this red engine to go into the outer siding when it gets around the loop. Now here's our additional delays dependent on toggle switches 21 and toggle switch 20, and it'll execute those delays same as before if these switches are closed, or if they're open, it won't. Now, after that amount of time, we just say accessory 10 reverse, which turns off the outer stop block, the LGB relay. So we don't know where the train is after we've turned that stop block off, but we know if we give it long enough, it'll eventually get around the loop from wherever it is and come into the stop block and stop. So on this little layout in the video, 9 seconds is pretty much enough to get it into the stop block. So we got to increase this time right here to get it into the stop block. And that's not bad on a small loop like you see in the video, but if this was a really big loop of track, you'd have to increase this time quite a bit to allow it to get around a big loop, so that stop could get kind of long. At any rate, now we're ready to run the other train, and notice there's no option in here to run just one siding or the other. There could be, except I was out of toggle switches, so I didn't put the option to run just one of the trains, but it would be easily enough to program. At any rate, we're ready to run the blue train, and it's pretty much the same thing. Turn the block on, delay 5 seconds, throw the turnout to curved to line it up for the inner siding, check for our additional delays, and turn the block back off, and then wait 9 seconds, which should be enough to trap that train, that is to say, to stop it when it's coming into the siding again. And then we link the input 29, which is down at the end of the program where we do our test to repeat or quit, and we'll go look at that next. Now here's the bottom of page 4, and we just looked at this statement a minute ago when we were looking at the commands for the blue engine. It says link to input 29, and that's down here. And this note says note that inputs 19 through 28 are not used. There's actually a bunch of empty inputs right in between here that we're not showing, that you could use for additional commands, like to run a DCC train point to point or do something else. But at any rate, we're linking down to input 29, and we're calling that our test to repeat or quit. And we're going to delay a half second. Then we're going to blink that LED on the mini panel. We use this accessory 2000 norm, which says set turnout number 2000 straight. Well, there is no turnout 2000, but the mini panel will send the command anyway, and in doing so, blink its LED, which is what we want. Now here's our test to either repeat or quit. Assuming we have toggle switch 18, that's our repeat switch, closed, it will not do the skip, and it'll see this statement linked to input 1, and that takes our action back to the top of the program, and we start coming in from the top of the program and doing it all over. However, if toggle switch 18 is open, which means we want to quit, then it skips this link statement, goes down to here to what we call our shutdown sequence, which for this program, we say accessory 6 norm, and that changes our status light from red back to green. And then we just have the terminate statement, which stops the mini panel from executing commands. Now finally, here's our program A, which we did in demo 5, which is a testing the detector program, where we pushed the car in front of the detector and it caused the turnout and the blocks to turn on and off. Let's do that again. There's the car blocks the detector, turns red, switch turnout cycles. Now you can see the stop blocks up there are cycling. Now back to the turnout. It goes to curved, then straight. Outside siding comes on, 2 seconds, turns off. Inside siding comes on for 2 seconds, turns off, and it keeps going through that. And this actually starts at input 1. When somebody pushes the button, the first thing that happens, push button, the start button is connected to the input 1 of the mini panel. So when somebody pushes that button, it actually starts here, and this accessory 6 reverse causes the NCE switch it Mark II to activate the NCE dual relay number 4, which is hooked up to the status light, and it changes that from green to red. And then we start our test routine. And assuming we've closed toggle switch number 25, which is the one that tells us we want to do the test routine, it'll skip over this statement and come to this statement. Now this is the one that checks the detector. If the detector is open, that's to say, not open, but if the detector is not blocked and the Z stuff relay is open, then this statement won't be skipped. It'll hit this link to input 5, and it'll skip around it down to input 5, which is program B. So what we're saying is if the car is not pushed in front of the Z stuff detector, nothing's blocking the Z stuff detector, it'll skip all these statements, go down to here, go down through the program, and assuming the repeat switch is closed, it'll come up around the top and come in here again. But now let's assume something, keep doing that. It'll keep cycling through, doing nothing if that detector's not blocked. Now, let's assume somebody pushes a car or something in front of that Z stuff detector that blocks it. That will cause input 14 to be grounded. So now when it comes to this statement, it will skip it if input 14 is grounded. It'll go down to here. Now this sets our turnout to curved, waits 2 seconds, sets the turnout to straight. Then the block on the outside track, it turns that on 2 seconds later. After we did the turnout, it turns that block on, waits 2 seconds, turns that block off. That's the outside track. We wait another 2 seconds, turn the block on the inside track, and then wait 2 seconds to turn that block off on the inside track. And remember, these on this display, the blocks contain the MTH power connector, which has a light bulb in it. So when we turn these blocks on and off, we can see that light bulb coming on and off. So that's all part of our tested detector routine.